Okay, today we're looking at the inequalities in one triangle, and one of the things we did in class was an activity where we each drew a triangle, measured the lengths of it, and then took a protractor and measured the angle measurements, and we did that, and we came to the conclusion that we will, right here, we'll just go ahead and continue on from that point. We came to the conclusion that the longest side of a triangle is opposite the largest angle. And what we mean by that, let's go ahead and get an idea of what I mean by that. Suppose we have a triangle, and we'll say that this is the longest side, this is the second longest side, and this is the shortest side. So we ordered it from longest to shortest. Well, what we found out in our activity was that the longest side is opposite the largest angle. The second largest side was opposite the second largest angle. And the third largest side was opposite the third longest angle. Well, basically, the shortest side was opposite the shortest angle. So there we have that. And before we talk about this exterior angle inequality, let's look at an example of that right here. So we're going to order this from smallest to largest. Notice, remember what we said, the longest side is opposite the largest angle, which means the shortest side is opposite the shortest angle. This right here, VT, is the shortest side, so it is opposite the shortest angle, which is angle X. This is the next smallest side, so it's opposite the next smallest angle, which is angle T. And 20.2 is opposite V. Okay? We'll look at another example here in a minute, but first let's talk about this exterior angle inequality. If you'll recall, we had an exterior angle right here, and you'll remember that that angle is equal to the sum of the two remote interior angles. So basically, angle A plus angle B is equal to angle 1. Well, if that's the case, what is the relationship between angle A and angle 1 as far as which one is larger? Well, if angle A needs to be added to angle B to be equal to angle 1, angle A must definitely have to be less than angle 1. Likewise for angle B and angle 1, same situation. Angle B has got to be less than angle 1. And that's what this exterior angle inequality says. It says that the exterior angle is greater than the two remote interior angles. So we'll look at an example of that on the next page. Okay, this one, let's go ahead and look at this one. This was that example I was talking about that deals with the angles. So we're going to label the sides based on shortest to longest. Well, the shortest side is going to be the opposite the shortest angle. The shortest angle is angle B. Opposite that angle is segment AC. So AC is going to be my shortest segment. Angle C is my next shortest angle, so that's going to be opposite AB, which is my next shortest segment. And the final angle, the 80 degree, that's my largest angle, opposite my largest side, which is segment BC. Okay, and the last part of our notes for this lesson, we're looking at angle 14. Remember, angle 14 is an exterior angle for this triangle. Sorry about that. Looks pretty sloppy. So we're looking for all the angles whose measure is less than the measure of angle 14. Well, remember what we just said. The two remote interior angles are going to be less than the exterior angle. So angle 4 and 11 are less than. Now what else can we get from that? Well, you'll notice that angle 9 is vertical to angle 11, which means angle 9 also is less than. If angle 11 is less than 14, 9 must also be less than 14. But at the same time, angle 9 is an exterior angle for this triangle right here. Well, it still follows by the same rules that the exterior angle is greater than the two remote interior angles, which would be angle 6 and angle 7. Now we can add those to our list. We have angle 4, angle 11, angle 9. We can add angle 6 and 7 because if angle 9 is less than angle 14 and angle 9 is greater than 6 and 7, then 14 must also be greater than 6 and 7. Okay, and our last example is, or last possibility in this situation, we have this exterior angle is exterior to this triangle, which means 9 is an exterior angle. It's greater than the two remote interior angles of 2 and 3. And we can add that to our list because if 9 is less than 14 and 3 and 2 are less than 14, or 9, then 3 and 2 are less than 14. So all the ones circled in red, written down right here, those are all angles that are less than angle 14, and we used the exterior angle inequality theorem to prove that. Okay, let's look at your assignment. Okay, the assignment 1, 8 through 12, the first section, you're doing exactly like we did on that last example. We're looking to see which angles meet the conditions listed on 8, 10, 11, and 12. Number 14 through and 18, we're going to have two lists. One will be based on angles, one will be based on sides, in order from smallest to largest. So we're going to find the smallest angles and list them first, and so on. Now look at number 14. We'll look at that one, at least the angles. It's a right angle, which means that W and Y must be acute or less than, because we have one right angle and we can't have more than one right angle. Well, which of those is larger? Remember, the opposite angle, let's zoom in here. This side is 23, or 2.3. This side is 3.4. 2.3 is smaller, which means the angle opposite 2.3 is the smallest angle, which is angle W. 3.4 is opposite angle Y, and we already said that angle Z was going to be the largest angle. Okay, so now you will do that again, but base it on on the sides. And if you know the angles, it's pretty easy to come up with the sides because it's the same way. The angle opposite, or the segment opposite angle W, is going to be the shortest segment, and so on. Okay, these problems, you're just going to circle the angle that has the greatest measure, so on number 25, which of those? We're looking at 2, 4, and 6. 2 is here, 4 and 6 are inside, so 2 is the exterior. 2 is going to be greater than 4 and 6 because those are the two remote interior angles. And you'll do the same for the rest of these problems. Numbers 30 through 33, you're going to be looking at the two angles and determining whether they're less than or greater than. 34, 36, the two segments, you're going to determine which one is greater than or less than. And the rest of those are some tricky ones. Number 40, again, you'll be using distance formula there. And The others, I'll let you work your way through those as well. So that's all we have for today's lesson.